Hi! In this lesson, you will learn about programming linear regression in Python. Once you have determined that a dataset has a linear correlation, you can develop a linear regression model. For this video, we'll be working with a dataset that relates the temperature to the number of cricket chirps per minute. We have determined that a set of data has a linear relationship by plotting the points on a graph and looking at the correlation coefficients. This dataset has a correlation coefficient of 0.98. As a reminder, the correlate coefficient is between 0 and 1. The closer to 1 the value is, the stronger the linear relationship. Linear models require the use of complex statistics and mathematics. Luckily, there are programming libraries out there that we can use to implement these algorithms without needing to understand exactly how they work. This is an important part of programming called abstraction. Rather than require us to rebuild linear regression models from scratch, libraries allow us to use the progress made by others. One such library is sklearn. sklearn is a machine learning library that provides public access to machine learning algorithms. sklearn includes a module that will enable us to create linear regression models. We can use it by simply including this import statement at the beginning of our program. Creating a linear model in sklearn is pretty simple. We start by formatting the data. We won't spend too much time on this step, but in summary, we're getting the x and y values from the file called chirping.csv. Then, we're turning the x values into a 2D array with the reshape method. Once we have the data formatted, we can create a linear model by calling the function fit from the linear regression module. This creates a linear equation based on the input values. This variable model now stores a linear regression model for this dataset. Now we can obtain useful information about the model. For example, model.coef underscore returns the coefficient of the slope. Model.intercept underscore returns the y-intercept. The r-squared coefficient is related to the r coefficient we discussed earlier in the module. The r coefficient determines the correlation between variables, while the r-squared coefficient indicates how well the model fits the data. Just like the r coefficient, its values range from 0 to 1, where 1 is a model that perfectly fits the data, and 0 represents a model that doesn't fit the data at all. This model has a high, strong r-squared coefficient, which means that it fits the data extremely well. We can use model.predict to predict a dependent variable for a specific independent value. Here we're predicting the number of chirps per minute when the temperature is 77 degrees. Because the prediction is based on the model, which is a linear equation, the prediction falls right on the line of best fit. One thing to note is that in order to predict a value, we need to input a 2D array value. This has to do with the fact that sometimes a model will have multiple variables instead of just an x and y value. Programming a linear regression model is that simple. In the next video, we'll head over to the live editor to see how this works.